Oh, no.
Oh. By the way, that's an acceptable use of technology during my class if you're going to use it to watch the Masters.
Fred almost put it where Phil was.
So Joey's watching football.
No, football's not acceptable, but you will never get in trouble for watching golf in my class. it's a.
Still playing the golf game.
I don't think that's acceptable.
Called the Masters.
Dude, 12's played placement today.
What did Louis finish at? 5 under?
Louis Oosthuizen? 3 over.
For the day? 3 over for the tournament?
3 over for the tournament, even on the day.
No, that's not right.
Louis Oosthuizen?
He's 3 over for the day, even on the tournament.
Yeah, so, or did I say it backwards?
Yeah.
Yeah, that's right.
Because he had it to 4 under, so he had it to 1 under today.
Yeah, Bubba stringed it together. And bogey 18.
Okay. So, remind me, we were dealing with...
Do something, I forgot what it was.
Is this the finish implementing this?
You're going to explain why it was true.
Why, what was true?
My reserved in parts 1 with the closed parentheses was true, I believe.
Oh, no. It was why we need to return true on it with the closing for the closing curly brace.
Yeah.
Because we did, in fact, see, this is our recursive call here, this match statement, right? Don't we call it multiple times? So here, let's just walk back through this real quick and bring ourselves up to speed. What does match statement start doing? It pops something off our stack, off our Lex Pez flippy dealy thing. As long as we have something, we're going to keep going. Otherwise, we're going to return false. So this is our don't try to logically deal with something that doesn't exist. Okay? So if we're here, we're going to go ahead and split apart our current lexical token. If we're looking at an opening curly brace, that is this production. There. Just like the searching algorithm I wanted to do there, it like literally made no sense. I was just going back and forth in different places. So if we see an opening curly brace, now what are we searching for? 0 or more statements followed by a closing curly brace. And the way we handled that is right here. That will match 0 or more statements. As long as this dot match statement returns true, as long as we continually match statements, we'll keep trying to match another one. As soon as it's false, we'll stop. Okay? Now, as soon as that's false, what should match next here? If I'm in this position right here, we're not going to write it right here, but just logically follow this. If I see an opening curly brace, I'll go ahead and print out that opening curly brace. Then I'm going to match, again, we're in this production right here. That is an opening curly brace followed by 0 or more statements, followed by a closing curly brace. This while loop right here, so for those of you who are having problems understanding that while loop, it's the while loop that does nothing. That's what that is. Okay, so I am... here, this is related. In Java, the rules for a while loop, it's while, open parenthesis, Boolean expression, closing parenthesis, statement. What statement were we using before? Semicolon. Semicolon is a statement in Java. That make sense? Okay, so I could just end it right there and just, this guy will just sit here and spin multiple times until finally match statement returns a false. So my question is when we finish, when we get past this while loop, when that while loop is finally false, what should we, if we were to pop the next token off the stack, what would it be? Not rocket science. If I read in the opening curly brace, then I read in as many statements as I could read in, and I finally finished reading in statements, what should the next thing that I pop off the stack be? Closing curly brace. That should be the next thing I pop off the stack. Correct? So the way we have this written right now, we notice the closing curly brace right here. Don't we? But we could replace this. See, we had to let this guy return true because we could potentially have something after a closing curly brace. If we look at our source code here, I still have my terminal open, I think. So for instance, here's my closing curly brace. If I return false there, I won't find the rest of that crap because I stopped looking. Does that make sense? So I need to return true. Alternatively, what I can do, and this is more in line with our look-ahead algorithm we discussed several weeks ago. If I'm right here, I know a closing curly brace should be next. So what will I do? I'll go ahead and I'll just say, just for the sake of argument here, let's just say lp.pop. Because we're assuming perfect syntax right now, we're not going to do anything with it. Oh, screw it. We'll do something with it. I lied. So we'll say parts is equal to decompose lex token of lp.pop. And then we'll go ahead and print out parts at bucket 1. And it should be a closing curly brace. Okay, so because this particular production says if we're in this guy, we're going to match an opening curly brace followed by 0 more statements followed by a closing curly brace. That's exactly what we're doing inside this if. If I'm looking at an opening curly brace, we matched it. That's the printing it out. Then match 0 or more statements. That's our recursive call. So this reads just like the production reads. Following, as soon as this is done, as soon as we pass this while loop, we know, assuming they wrote perfect syntax, that's the whole next step after this, we know that they will read in, that we will read in a closing curly brace. So we'll read it in, we'll split it apart, and print it out. And by doing that, we no longer have to have a specific check for the closing curly brace. Why do we want it to work that way? We want match statement to match within a statement, where we want each individual thing to match individual productions of a statement. Okay, and this is going to make more sense when we get into, what do we match right now? We match ifs. So we match an if. Our if looks like this. What comes next? We want to match an opening parenthesis, an expression, although I think in our current thing we're saying expressions don't exist, right? So nothing. So our if is the word if, followed by an opening parenthesis, closing parenthesis, followed by a statement. So watch how this spells out. And we're going to do this similarly what we just did up here. If we're dealing with the production that starts with an if, we'll go ahead and print out the if. Actually, just to make this look, I guess, well, it doesn't matter. We'll print out the if. Then we're going to go ahead and we're going to do this line right here, those 2 lines. That'll print out the opening opening parenthesis. That'll print out the closing parenthesis. Except I'm missing some semicolons, but you get the point. So because I just read in an if, when I pop the next thing off the stack, it will be an opening parenthesis. Again, assuming perfect syntax. Why? Because that's what an if statement is. It's the word if, followed by an opening parenthesis, followed by a closing parenthesis, followed by anything that's a statement. Okay? So we print out the if, match the opening. So I'll actually put comments in here. Then match opening parenthesis, then match closing parenthesis. Then what do? Match statement. That makes sense? And who knows how to match statement? This method knows how to match statements. Now we don't need to look for closing parentheses. We don't need to look for opening parentheses. So here, we'll actually just do an else, return false. Kind of for consistency reason. If we're in this else, that means we did not match a statement. It's even clearer now than it was before. Let me minimize this here. So right now, we're allowing our language to support two different productions. We're allowing it to support the production that is the statement that starts with opening curly brace, as well as the production that supports the statement that begins with the word if. How many if statements, or how many if statements inside of match statement do we have? We have two. One for the first production, one for the second production. And then we have our catch-all. That's not a statement by our book. Okay? So this is our look ahead. Now, we can kind of think ahead here and see that we could put syntax checking in here, couldn't we? If we're expecting, for instance, down here, if we're expecting an opening parenthesis, and we go ahead and read in the next thing, couldn't we then just ask the question here? Am I looking at an opening parenthesis? If I'm not, scream, expected opening parenthesis. Does that make sense? Wouldn't that be kind of consistent with what the kind of feedback the Java compiler gives you? It'll say something like expected semicolon, certain line or something like that. Okay, that's how it goes about doing it. Okay, what's this guy screaming about right now?
We don't always return Boolean.
Sure I do. So this is true, else if that is true, else this. Oh, it's because I don't return any Booleans in here. That's why. The easy ones are the ones I forgot to do. If we do fully match a opening, closing, curly brace statement, I want to say I matched a statement. I'd like to return true at the end of that. Similarly, if I match an if, I also want to return true. That make sense? So go ahead and run this. Row. Actually, it looks like, did it get everything and then just die on the end? So we got the first if, opening curly brace, if, open close, opening curly brace, if, open close, opening curly brace, if, we just got to close. Did we get an extra open one somewhere? No? Okay. Let me down in Syntax Analyzer, let me just quickly run through all of our lexical tokens. Let's just make sure we're parsing it correctly. Because I think this should work. for string S. Well, actually. Oh, doesn't LexPez know how to display itself? If open close, if open close, if open close, if open close. Okay, it looks correct to me in here. Okay, so we must have written something poorly. So match statement grabs the top of LexPez, grabs the top of the stack. As long as it's real, we're going to decompose it. If we're looking at an opening curly brace, then print it out. Then as long as we keep matching other statements, call this. Finally, we should read in our closing curly brace. So this should be a closing curly brace. And we'll return true. Finished matching an entire statement. Else if we're looking at an if, we'll print out the if, then we'll grab the next thing on the stack, which should be a opening parenthesis. We'll print it out. Then we'll grab the closing parenthesis. We'll print it out. And then we'll match the statement, because an if is followed by a statement. Okay, so why doesn't that work? Run it one more time. Oh, that's still displaying. Hold on. We might have to go to our debugger here. And just for the sake of sanity, yeah, that's fine. We'll just made it a little shorter than it was before. Make sure it still breaks. Interestingly, we do find all of our open closes now. What's actually bailing out inside of decompose lex token so just out of, let's just do a system.out.println decomposing LT. Let's see who he's dying on. So every time we decompose, we're going to just print something out. All right, so we're decomposing a null at the very end. Why would we be doing that? If we check her token for being null first, it has to be happening somewhere in here. Okay, so we know it's happening. We know we're trying to decompose a null. So that's why it's crashing, but we need to see where it's occurring. So we see an opening curly brace. So let's just trace through the way we think this logic should work. We see an opening curly brace, fine. So now what are we going to do? We're going to match 0 or more statements. So we call match statement again. It matches an if. That should meet one of our productions. So we'll match the if, match the opening parenthesis, match the closing parenthesis, match a statement. So that statement starts with opening curly brace. That guy's going to match 0 or more statements. Call if. Open parenthesis, close parenthesis. So this is all matching inside of the same if statement. So we match this. Then we say, oh, since it's that, let's match this guy. Let's match this guy. So pop, pop, then match a statement. We'll pop the if off, then pop, pop, then match a statement. Then we'll try to read in 0 or more. We'll get a false right off the bat. Why will we get a false right off the bat? If we're in this else, we got to think about how the Booleans return. All right, we're gonna need volunteers. By volunteers, I mean I'm just gonna point to you. I'm gonna assign you parts of this. Okay, so Matt, you're the first call to match expression, or match statement rather. So we just found a opening curly brace. So we're in that first if statement. So now Matt's job. So Matt is currently inside of this if statement right here. We just matched the opening curly brace. So now he's going to go ahead and print out the opening curly brace. We see it on the screen. So we should see this displayed on the screen. Then he's going to try to match some other ones. So Matt gets put on hold while he goes and looks for another statement. Okay, so Matt, you're stuck right here. Remember that. All right. Now, we read in the next token. Next token should be an if. We get it. This was our first time through our loop in here. Where's my loop? Right here. My first time through here, we match an if. So we come into this version of match statement. This is Simon. So Simon, we're in this version of match statement. We just matched an if. So Simon's going to print out an if. We should actually just see it. We should see it displayed. Then we're going to grab the opening parenthesis. We should see it displayed. Then we'll grab the closing parenthesis. We should see it displayed. And then we'll match another statement. So this is what Simon did. He found the if, printed it, found this, printed it, found this, printed it, then called match statement. So Simon, you are now stuck right here on this line. You're waiting for that line to return. Okay? So we call that line. Now coleslaw. We call match statement. What do we find? An opening curly brace. So coleslaw is in this if statement. So we print out the opening curly brace. So he does that. Then we match 0 or more statements. So coleslaw is currently waiting for this guy to finally return a false. Okay, so he's on hold. So we're seeing live recursion, if you will. Okay, so this was you, coleslaw, right here?
Yep.
Okay, so now, Tina. This is our first time through coleslaw's while loop. We're matching another statement. we're going to match an if. So Tina, you are in this if statement right here. Okay, because we just matched an if. So what are we going to do? We're going to print out the if. So Tina, you displayed that. Then we'll match the opening parenthesis, display that, match the closing parenthesis, display that. Then you're going to wait for match statement to return. Okay, so Tina, you're waiting on this line. Okay. So that takes us right here, correct? So this is our next token when we pop. So now we pop. This is Baker. This is Baker. So Baker, we just got into this production for Baker. Found an if statement. We'll print it out. Then we'll pop the opening parenthesis, pop the closing parenthesis, print both of them out. Baker's now stuck right here. That gets us right here. So now we're waiting for this call to match expression. So this is Carrie. So Carrie, you are the next call to match expression, or match statement, I'm sorry. And you're in this production, the one that starts with an opening curly brace. So we'll print out the curly brace, and now Carrie's waiting on this guy. A while loop that's going to try to match more. Okay, so she has to wait for that to return. Okay, so then we just read in the opening curly brace. What's the very next thing we read in? Closing curly brace. Okay, this is where our problem is. Okay, so Ian, you're always a problem. So we'll go with you for this one.
Hey.
Ian's where the issue is. So, and we skipped voltage for obvious reasons.
I never really caused a problem or.
All right. So now we're on Ian's call. You really need a nickname because Ian just doesn't sound right to me. So we'll work on that. So we come up here to Ian. What's the very next thing we're going to pop? We are going to pop this guy right here. Correct? So we'll pop that closing curly brace. We popped it too early, right? We didn't want the closing curly brace. So cur token right there is the closing curly brace. The problem we run into now is, Ian, you're going to say, well, is it nothing? It's not. We're good. So we're not going to return false yet. Now we're going to split it. Okay, fine. We can split it. No harm, no foul. Is it this guy? Nope. Is it this guy? Nope. Else. Return false. We have an issue. You just returned false, but we still removed that token from the stack. Correct? What should we have done before this? Push it back on there. Do we not write a push? What kind of stupid Lex Pez is?
Add.
Oh, we called it add. Okay, thank you. LP.add cur token. So this is push it back onto the stack. That makes sense? So Ian, you're going to read in the next token, you're going to read in the closing curly brace. Then you're going to say, okay, well, it's not this. It's not this guy. It's not this guy. So I don't have anything I can do with this. So what am I going to do? I'm going to just put it back onto LexPez because, look, I took the magazine off the top of the stack. I can't do anything with it. So I'll just put it back and I'm going to leave. Okay? So literally, Ian wasted time. He removed something from LexPez, did nothing with it, and then put it back after wasting time asking some questions about it. Okay? So we put it back, return false. Now we're back to Carrie. So Carrie was waiting right here. Correct? That finally returns false. When it returns false, we fall past it. Then what do? We match the closing curly brace. Which fortunately for us, Ian just put back. Okay? So now Carrie will pop it off the LexPez and print it out. and then return true. Okay, now Carrie is done. We're back to Baker. What were you, Baker?
The second if, I think.
You're in an if. You're an if. Okay, so Baker just finished matching statement here, correct? So now you're going to return true. Okay, so now Baker's done. So now we're back to Tina. Where were you, Tina?
Love that. Using an if.
He was in an if? Okay, so Tina, you're stuck right here. So you're going, well, actually, you just finished. Baker just finished, so now you can move past this line, and now you can return true. Done matching an if. Okay, now we're back to coleslaw. Where were you, coleslaw?
Opening parentheses.
You were opening curly brace, you mean?
Yeah, sorry. Opening.
Okay, so you're inside this while loop right here. Okay, so Tina just returned a true for you. So now coleslaw loops back up. Now he's got to call match expression again. Correct? Okay, so we need to now figure out where you were here. So coleslaw is not done yet. He's waiting for iteration number 2 through his while loop. Okay, Tina just finished, returned a true. Okay, matched one statement. Let's try to match another one. Remember, the first production matches 0 or more statements. All right, so this was Matt, Simon,
Yep.
coleslaw. So this was,
Tina.
that was Tina.
Scott.
This was Scott. Okay. Then this was Carrie. Carrie finished. Scott finished. Tina finished. Okay, good. So now we're going to call it one more time. Who's next? Ali? Okay. So Ali, you're going to call it. We're going to call it again. Match expression. That is coleslaw. His second time through a while loop, he's going to call this dot match statement. Sorry. So that's going to be Ali. Match statement gets called. Ali pops the guy off the top of the stack. What he's going to pop off is this guy right here. So almost as much trouble as Ian is Ali. He's going to pop off a closing curly brace. He's going to say, okay, well, I got my closing curly brace. It's not null. It's not this guy. It's not this guy. I'm basically useless, so let's put it back on the stack and return false. Thank you for your time, Ali. Okay, so Ali just read in that guy, put him back on the stack, and returned false, which then brings us back to coleslaw. Coleslaw now gets a false right here. His while loop fails, right? So we get a false. Then what does he do? You pop the closing curly brace off, as you were expecting, and then you print it. And then you return true. Coleslaw is now done. So that was coleslaw right here. That was where he finished. Okay, now we're back to Simon?
Just the if. Yeah,
Oh, the if. So now we're back to Simon.
I was at the.
We just finished right here. Simon says, thank you. Turn true. Simon doesn't do anything else, doesn't pop or push or anything like just, look, I was just sitting here. Somebody else said they were done, so my work's done. Returns true. Simon's now done. Now we're back to Matt. Matt, you were in this while loop right here, correct? Okay. Now, so you just got a true from Simon. So that means Matt read in a true, so he's going to loop back up and try to do it again. So you're going to match another statement. So now we're to Skippy. Oh man, we're going to almost do the whole class. Pretty close. So now we're back to Skippy. So Skippy, we are going to pop off what? You're going to pop the closing curly brace here. So you're a waste of time. Similar to Ian, not as much as Ali. No, more than. No, I went backwards. Ali is less than a waste of time than you. You're slightly less of a waste of time than Ian. Ian's the worst. Well, maybe voltage. All of it's recorded. Okay, so Skippy, you're going to pop the closing curly brace. You notice it's not null, but you also notice it's not this guy, it's not this guy. So you're going to go ahead and put it back and return false. When you return false, that's going to allow Matt to finally exit out of his while loop here because it finally returns a false. Then Matt will go ahead and pop off the closing curly brace, the one you just pushed back on. He'll pop it off, display it, return true. Okay, so that's going to return true to what? Who did that return true to? This guy right here. The original caller. Let's say me. The guy who hit the play button. Okay? So there's all our matches. That make sense? I think it gets everything, doesn't it? Okay, so our problem was that we weren't pushing the closing curly brace back onto the stack. Okay, questions about this? So now we have this as a starting point. For your homework, I'm going to actually steal all of these, but I'm only going to have you write some of them. Let me do this. Go to the drop. Why do I suck at clicking so much? It's the shakes. Like I have to just use my index finger because I use my thumb, and sometimes it does when I push, it does the weird skippy thing or something. And you know how weird Skippy is. All right. Eclipse. Move that to trash. Compress. Okay. So is Angel just down? It's good.
Huh? What's up? Quay?
I think Angel must be down.
Oh, yeah.
We'll let it keep loading here for a second. But what we're going to do for our homework is similarly to what we did with the if statement here, we're going to pretend like expressions don't exist yet. So we're going to still keep this simple. Okay, so for your homework assignment, I'm going to have you do the secondary type of if statement, the one that also includes an else. Okay? So you'll be able to use our first two ifs, the one that matches an opening curly brace, the one that matches an if, but then you have to check, one more look ahead, is the next guy an else? And if it's not, you got to put him back. Make sense? So hopefully we start seeing the power in using a stack for this. Okay? So you'll do this, say this again?
Yeah, stacks are pretty powerful. Fat stacks.
Just dumb. Okay. Okay, so we'll do the secondary if statement here. We'll also do a for loop, except a for loop, we're going to leave all the inner parts out. So a for loop will be for, opening parenthesis, semicolon, semicolon, closing parenthesis, followed by a statement. How come we didn't put a statement on here? That makes sense? But you won't be matching the for part one expression or the Boolean expression or the assign expression. We're leaving those things out to keep. So everything right now, we're just matching statements. Okay? Also, you'll match the while. That is a while followed by an opening parenthesis, followed by nothing, followed by a closing parenthesis. So just like the if, it'll be while, opening parenthesis, closing parenthesis. That's what you're matching, followed by a statement. Do, same exact thing. And that's it. Those are the ones you'll match. Okay, let's give this one more shot. Maybe it's loading. I always thought a really funny joke would be at some point, you know how some people would start typing too quick and like they accidentally put their password in like the username box or something. Like do that, but do it on purpose and put like a horrifically inappropriate password. It's like completely plain text.
Whoa, whoa.
Whoa!
My strategy.
just backspacing it.
You should not.
No, you just like leave it up there. Why isn't it working?
Yeah, I just keep trying to log in, just playing completely stupid, and everybody out there is like cracking up.
So he's like, is that your password?
Is that?
My password for a long time for RuneScape was take a guess. So that people would ask me who was password. Take a guess. And they just walk away not knowing. And I told them. I told you.
So security through obscurity.
Yeah. Security through awesome.
That's kind of like the logic of no one will expect my password to be password.
Way back when I guess the internet first started. Back then, probably before most of you were born, my password was the early days. It was just QWERTY, you know, top keys. Then when they made you put a number in, it was QWERTY 7, because you know I had to,
It's right above.
yeah, right above the Y is the 7. Get it? So we're still trying to log in here.
It's probably still down. Apparently some Microsoft tech deleted like a bunch of DNS settings from Korea.
Oh, that makes sense.
That's what I was told.
Okay, well, in any case,
Pretty cool dude.
does everybody understand what I'm asking you to do? Is it clear? What I'll do is when I can finally put it up, I'll try to put it up here in the next hour. I'll just keep trying. Worst case, I'll put it up tonight. I'll give myself a reminder so it will go up tonight. I'll give you the productions that I want it to work for. I'll include the 2 we've already done. That way you can kind of see how it matched up to it. But I'll edit the for and the while and the do while so that they look exactly what I want you to match. Where expressions don't exist and for part 1 expressions don't exist. So a for will just be for opening parenthesis, semicolon, semicolon, closing parenthesis statement. That make sense? So I'll modify it so you see exactly what you have to match in the homework assignment. Make sense? Questions, comments, concerns, bribes. So all the code you will write, all the code you will very, 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 very likely write should be inside of match statement. It should be adding additional if statements in here. Does that make sense? Okay. I will see everybody on Tuesday. I'll get this uploading and then try it again. Monday. See you on Monday. Sorry. I thought this was Thursday.
I'll be over soon.
Yeah.